Hello, my name is Dan Williams, and I'll be showing you how to cluster survey ranking question responses using Python. Our example will use real survey data from a marketing product feature survey, though the exact product features have been changed to protect the business interests of the organization that conducted the survey. We'll start with raw SurveyMonkey data and end with product design recommendations generated from the analysis. This procedure requires Python with the NumPy, SciPy, and Matplotlib libraries installed. For Windows users, Enthought's Canopy distribution contains the necessary libraries. Since the source code may be difficult to see in a YouTube video, I have posted it along with the slides at the address pictured here. Please note that the spaces between the words in the URL are actually underscores. Here is a list of product features and their corresponding codes. As you can see, these features are not the real ones used in the original survey whose data we are using. Survey takers were asked to rank the features in order of personal priority. For example, a respondent may value C most, then D, E, G, H, A, B, I, and finally F. This is what survey designers call a ranking question. Ranking questions may be taxing on survey takers since they require the respondent to keep track of multiple items in order to rank them, a fact we will consider later. We start with the raw SurveyMonkey results pictured here. The first line states the instructions the respondents were given, while the second line lists the options which each respondent was to rank. Lines that follow indicate each respondent's selection, one respondent per line. Blank lines indicate cases where no selection was picked. We need to parse the raw SurveyMonkey results into ordered lists of selections for each respondent. The code on the lower left performs this task by iterating through each line and compiling an ordered list for that line, giving the selections from most desired to least desired feature. Output showing the ordered list is presented in the lower right. For example, respondent number 258 prefers option E, then A, with C last. Results are stored in a list called respondent rankings, where each index of the list corresponds to a respondent. We now have each response stored as a list in order of product feature preference. We next need a way to compare each response to every other response so we can populate the similarity matrix necessary for clustering. Given two responses, I devised the following method for scoring their similarity. I started by selecting the first two features from each response and divided the number of selections in common by the number of unique selections, after which I multiplied by 2. I stored this value as x. Then I selected the first three features from each response and similarly divided the number of selections in common by the number of unique selections, after which I multiplied by 1.5. I stored this value as y. Finally, I selected the first four features from each response and similarly divided the number of selections in common by the number of unique selections, after which I multiplied by 1. I stored this value as z. I then added x, y, and z to produce the similarity score. This scoring strategy reflects the idea that the first two and first three selections are most important to the respondent, and that the order between the selections 1 and 2 and 2 and 3 probably matters little. The scoring strategy also completely ignores the effect of the last 5 selections. I chose to ignore these last 5 in the score since ranking questions are taxing to respondents, and who therefore probably gave the last few selections little thought. The code on the lower left shows the computation of the similarity scores for each pair of respondents, which is then stored in the NumPy matrix shown on the lower right. Notice that the diagonals contain the topmost similarity score, which reflects the score of a sequence of selections compared to itself. To cluster, we need a normalized similarity matrix. We compute this by dividing the similarity matrix produced by the code in the last slide by its maximum value. Now the value in the diagonals equals 1. We now produce a hierarchical clustering of the survey responses using the scipy.cluster.hierarchy linkage command with the average method saved into the variable linkage. From this we can then produce a dendrogram of the clustering results as shown on this slide. From the hierarchical cluster, we can then form flat clusters representing groups of survey respondents using the fcluster command in scipy.cluster.hierarchy. In this case, we divide the respondents into 5 such groups. The resulting group membership list has the same indices as the respondent rankings list seen above, so we know which responses were selected for each group. We now need information that will help us make product recommendations from the flat clustered groups. This block of code calculates the frequency with which a product feature is listed as the first selected item within each of the clustered groups. For example, we see from the output that group 5 respondents start with B 20 times and E 53 times. Therefore, to effectively target this group of respondents, the product must include features B and E. Similarly, features C and E dominate the responses for group 3. Alternative ways of analyzing each group's member results for the product recommendations are possible, just not considered here. For example, we might consider the first 2 selections for each member of a group in the analysis. From the analysis presented on the last slide, we make the following recommendations. Try to get E, B, and C into one product. If that does not work, try to get E and B into one product and C plus E into another product. If that does not work, get E into one product and B into another. I hope you have enjoyed this presentation. Thank you for your time.